in a certain country, the number of rainy days is June is observed. You may assume that the weather in each day is independent, so don't worry, they're independent of the weather on other days. In context, we have to state an assumption needed for the number of rainy days in June to be well modeled by a binomial distribution. And the probability that it rains on any given day in June is P, right? So for the first part, right, to remember that the conditions, right, this is very important to state assumption needed for the number of days in June to be well modeled by the binomial distribution. This in the context, we have to say a few things, right? Because we want to model this in the binomial distribution. Again, you must say, for example, they already told you that the trials must be independent, which they already told you that the rainy weather on each day is independent of the weather on any other days. Well, else do you know? You must know that the probability of success must be the truth, must be the same in all the trials. So here is not stated. So very simple here. How do we express it in terms of the context of this question? Is that we need to say maybe like the probability of rain is the same each day for each day in June. The probability of rain is the same for each day in June. Alright, and with that, let's look at part 2. The probability that it rains at least once in a sample of 15 days in June is 0.96482. We want to write down an equation. Probably let x maybe be the number of days. So we will define a variable again, because we always have to define days out of 15 in June that rains. Alright, and then x will take on the binomial distribution of 15, comma p. Okay, then after that, what's the probability that x is at least greater or equals to 1? So from here, we do not know what is p. So the thing is, now we need to find the value of p. So here, we can't use the GC to help us. We have to go back to the fundamentals as we use the original function of the binomial distribution, right? Which is n choose r. Remember, it's n choose r, right? Then p to the power r, 1 minus p to the power n minus r. Here, this probability of x greater or equals to 1. What do we do about it? This is the same. It's not 1 minus the probability x equals to 0, am I right? Alright, we want this to be equals to 0.96482 as given in the question. So that means the probability of x equals to 0. If I were to manipulate and rearrange this equation, it will be 1 minus 0.96482. It will be 0.03518. Alright, using this is the same as 15. Choose 0, p to the power of 0, and 1 minus p to the power of 15 to be equals to 0.03518. Now 15 choose 0 just be 1, p to the power of 0 will be 1, and with that you are looking at 1 minus p to the power of 15 to be equals to 0.03518. Now do the math yourself. You can log both sides, you can use the GC, and eventually just go to solve, and you got p equals to 0.2. Alright. So next part, alright, we look at part 3. And given that p is equal to 0.25, okay, so now what's the most likely number of rainy days in June consisting of 30 days? So now, again, we need to define another variable. Okay, so always define. So now we're looking at not the original question, but it's no longer 15 days. So b, the number of okay, so y, we'll take on a binomial distribution of 30, and your p is 0.25. Okay, and then working in the GC, what I do is you just go to GC. What you can do is you can key in the y1 dash, and then look at the most high, the value of n that gives you the highest probability, and you notice that in fact when n equals to 7, point y equals 7 is 0.7. 16624, right? So this is actually the most probable value, most likely, is actually equals to 7.